Welcome, everybody. We're working on the chapter 5 exercises tonight. We have a few of them to go through, and we're just going to kind of plow down the first 3 exercises here. As I was just mentioning before we were getting started, that unlike what we did in the previous chapter, where we had like multi-part exercises where each one was a separate program, in this case, the multi-parts are all going to become functions inside the same program, right? And this is one of the advantages of doing this approach. And just remember, a function is a named block of code is really a good way to think about it, right? So inside Spider here, I'm going to close all my open programs. I got a new one created, immediately going to do a save as, find the correct folder for this semester, this class, and this semester. I'm just navigating to my standard setup here. We are now in unit 5. So all my code's going to go in this folder. And this is exercise 5.1. So I'm calling it exercise 5_1. And I'm zooming in on both panels to make it a little bit easier for you guys to see. All right. Next thing I'm going to do is I'm going to take a look here at the description. Write the following functions and provide a program to test them. And so what I'm going to do is I'm just going to copy this information, and maybe I should grab the A and the B. And I think I figured out last time I have to hit that copy button to get the copy to happen. And then I'm just going to put those instructions up here in the comments area just to have them handy. Now, before I get to coding the solution for this, I did mention during our Kahoot that there's a convention that happens in programming that a lot of people follow in Python, right? Which is like, and I look to the C style languages for this, namely, C, C++, C Sharp, and Java, where they often run their programs off of what we call a main method, right? And it's required in the program. Otherwise, the program just will not execute, period. We already know in Python, I can just do a print statement and this will execute just like this. I don't need a main method or main function. But because we want to kind of follow good programming practice, I am going to define a main method. And notice the procedure for doing so. You use def as the keyword. You name the function, whatever you're naming it. It cannot be a reserved word, followed by a set of parentheses and a colon. From there, when I press enter, I will be indented, right? And so I'm just going to put a little comment here. My main method stuff will go here. And then I'll also add a little note. This will not automatically run, and instead of this, I should say main will not automatically run unless I explicitly call it. And so right now, anything indented here, and I should probably say anything indented, is part of the main method, right? So it's all inside here. So anything that's indented is part of it. So if I do like a print command here, that's part of the main method. And just to prove it, I'm just going to type in some silly words there. And then I'm going to go down a couple of lines, go back to the margin, and let's run the program. Right, so here comes the run. And there it is. It works. You guys notice what happened? Nothing. This is kind of the point that I was making in the Kahoot, is if I have a function definition and run the program, and I have nothing else in the program, nothing happens on the screen. I have to call the function to run. So I just say main with parentheses, and now it will execute the code and put, oh, wow, on the screen. So whenever you use the main method in a program, always remember at the very bottom somewhere, throw in a main method call. And this is kind of usually what I do, is I just pre-create it, push it all the way to the bottom, and leave myself some space. Now, the other thing that we're going to do right? So this is just a demo, by the way, is we'll define, other functions, right? That will do other things like this. And then in order to get this one to operate, I'll call it from the main method, right? Like this. So I'll just say other. So when I run this program, this won't execute. This won't execute. This will, which goes up here, reads the block of code, then it prints, then it's other. That's how it operates. If I omit this statement, nothing happens, right? So watch. Both of them worked. If I skip the main method call and just run other, it just does what the other is, right? But this isn't really the way we want to do it. The thinking is, and this is what we do once again in all the C style languages, is the main method or function steers the program. So we do all the main stuff we need to do in the main method, and then the functions that we're calling do all the specific tasks. And so when we run the program, we just call the main method, which triggers everything else to happen. That's the mentality that we're applying here. All right. Now, these were silly examples, but you get kind of the point, hopefully. I'm hoping, right? And really, you see the point when you start like really running the code a little bit deeper. And let's try to solve this problem that we have on the screen right now. So we're going to do exercise 1, and it wants us to do the smallest number and the average number. And I want you to notice that each one of these is receiving these 3 values. All right. When we're sending the arguments, when it's receiving their parameters, right? So if you want to repeat that in your brain, functionally unimportant to remember. It took me years, honestly, to remember that silly piece of information. And then you start working professionally, and then you realize real programmers don't care, right? It's like parameter, argument, whatever. It's the stuff inside the parentheses. It works. Okay, good. So don't worry about definition on that too much. All right. So I'm going to need to take some numbers to send in. So why don't I do this? Okay. I'm going to need to, well, could I just take some numbers and like hard code them? So could I do like a num1? Yeah, I could do all that stuff, and I'm not going to, right? My focus really is on getting the functions to work. And you know what? They're telling me what to call them, and they're giving me a parameter list or an argument list. So I'm going to copy that as is and just drop it into my code. Notice this is all the way at the left margin. It's not indented. If I indented this, it would be part of this method. Not that that's not possible, but that's not where we're going, right? This is inside. This is its own standalone function. So how do I determine, based on 3 incoming numbers, which number is the largest and the smallest? Now, I don't know if you guys remember this, but when we did if statements, we did this exact thing, right? Okay, so so the logic, what I'm telling you is the logic's already kind of decided. So we can figure it out. We're sending in an X, Y, and Z. So we know that if X is less than or equal to Y, and X is less than or equal to Z, then X is the smallest. So if X is the smallest, I want to send the value of X back to the program. So I would do a return statement here, and I'll say return X if this is true. And you can see I'm like in like SQL mode. I'm pressing semicolons and stuff. I don't need to do that. All right, so that's the one scenario. The other scenario is if Y is less than or equal to X and Y is less than or equal to Z, then Y is the smallest, and I'm returning Why? And notice this is not an else if. You guys picking that up? Then the third scenario is you might go, well, if Z is less than Y and Z is less than X, right? You could write that statement. But the truth is, if the first two statements don't catch, if you like reason through all the possibilities on this and look at all the permutations, I think is what we call it, you would discover that if the first two scenarios don't catch, then Z is the smallest, as simple as that. So I'm just going to return Z. So here's an example of a function with three return statements. Only one of them is going to hit, though. If X is really the smallest and it returns here, it's not going to process the rest of the code. This bumps it out of the function and takes you back. And not only that, but wherever the function was called from, it's sending that value of X back to it for further processing. So if I was to call this from the main method, here's how I would do it. First, because the function is returning a value, I need somewhere to put it. So I create a variable. I'm just going to call it num, right? What's going in that variable? The result of the function. So I'm just going to say smallest, because that's what I call the function, right? Call it by name. And notice, thank you, Python, right? Thank you, Spider, for autofilling for me. But it realized, how did it do that? Well, here's what it did. It recognized that smallest was a function inside my program. It read the parameter list and then automatically transported it back to my code. Because, hey, if you're going to call that function, you got to send three values and you really don't have a choice. So, okay, so now the problem is what's XYZ, right? Okay, well, I can define XYZ as different numbers. In fact, instead of defining X, Y, and Z out here, what I'm going to do is I'm just going to hard code three values in here, right? And then, so I'm going to send those three values in, and then I'm going to print the result by just outputting the number. So whatever number it returned, we're putting back on the screen. So let's just try that so far. See if this works. Here's the run. Yeah, one is the smallest. That is correct. Could I change the order? Okay, so for example, if I took this and ran it again, but I put in, I don't know, 11, I could put in different numbers, right? And run it again. Is it finding the right smallest numbers? Yeah, it is. So you can test that. In fact, you could also do it like this, and I'm just going to show you, basically because you need to have somewhere, because this is returning a value, right? One of these three is going to return. This has to have somewhere to put the value, so you have to have a variable over here, or you could do it like this. You could write a print statement and say the smallest number out of 5, 6, 7 is, right? And then you could put your, and actually we don't even need the space there, put your comma in there, and then I can run the function with 5, 6, 7. This will print out this text, call the function, send it to numbers, return a value, and then add that value here. Pretty clever. But once again, this is returning a value and it has somewhere to go. Where is it going? Right here in the string that we're outputting. So here's the run, right? And this output is probably a little better, right? The smallest number out of 5, 6, 7 is 5. That's correct. Right. This is just text, right? The first part of it is just text, but this is calculated by the function, the 5 is. And then, of course, you should try different values, try different orders, play with it a little bit and ensure that it's working. So however many statements it takes to prove that it's fully working, that's how many you should put in. And I would probably prefer that you do it like this, but whatever, as long as I can see that you're getting the correct output. All right, so that's running the smallest function. Now it's asking for another one called average. And once again, we're using XYZ. And so I'm going to come down here and define it. Somebody have a question? Nope. Okay. All right, so now we're defining another one called average, which is going to accept three values, X, Y, and Z. And then, all right, so how do you do an average of three numbers? All right. Well, an average is basically, right, set up a variable to receive the value, is when, if we have three numbers, we're going to take X plus Y plus Z, right? It's inside parentheses because we have to do the math or the addition first. And then we divide it by the total number, which is 3. All right. And then ultimately, I just return the average, right? So let's try this one. That's pretty easy little equation, right? Yeah, it really is. All right, so let's try this one. So right, you can see I'm indented. I'm in the main function. And now I'm going to do the same scenario. I'm going to take that number variable. Doesn't matter. I've already used it, right? Just keep the same variable going. And this time I'm going to call the average function and I'm going to send in, I don't know, pick some numbers. And what I'm going to do here is do something really goofy like, I don't know, 6, 7, 8, right? Separated by commas. What's the average of 6, 7, and 8? 7, right? Because it's right in the middle. That's why I use really easy ones like that. And then once again, we're going to output the value of number afterwards. So, all right, so 7. And notice because it's doing division, it's extrapolating or casting out to be a floating point number. Right. The better way, of course, to do it would be maybe to have a little bit more verbose statement, right? Like I did with the smallest thing above, where I said the average of 12, 34, and 45 is, I can send it to the function, returns the value, drops it in right here, concatenates it to the string. So here comes the run. Right. The average of 12, 34, and 45 is 30.333 repeating. Couple things I want to throw in here, though, just to kind of clarify a couple of situations that we might run into. People that have experience in programming will look at some of this and go, isn't there a better way to do this? Okay, so there's a couple better ways to do this. I'm going to point out one. Here down in the average, by the way, you notice that I'm doing the calculation, right? Here's the calculation. And then I'm storing it in the variable. So it's occupying memory storage, right? And then I'm returning the stored value. Or, and here's the or, right? Here's what you could do instead. And I'm going to comment out this line here. Or I could just take that calculation, by the way, and just do it like this. This is like brute force. I'm not, what's clever about this is I'm not storing it, right? So if you're looking for like program efficiency, because I'm not storing it, it's just performing a task, right? I can call it, performs a task, sends the number back. I don't need to occupy memory, right? Experienced programmers, if they know they don't need to reuse the value, they'll do this approach, right? If it helps you to think through the problem, use this approach. So, and I'm what I'll do is I'll just add it as an option here, and I'll say, or you can do this. Return, and then I'll just take that equation. Right. And this stuff comes with practice, right? The more you code, the more you see this kind of stuff. But either way it works. As long as it's returning the right stuff and doing the right thing, then the function's working. Yeah, and some functions that are built into other people's APIs or you know, libraries of functions are really simple ones like this. Some are not. Some are really, really complicated. We have no way of knowing. It's a black box. All right. I'm going to save this. Everybody okay? Everybody got it to work?
Yep.
Okay. Thank you. At least I got one person to respond.
I kept getting an error, but it was because I had commented out that first def main that you put at the top, and then it
Yeah,
kept
yeah.
saying indent error, and I'm like trying to tab over, and I'm like, what is going on? And I just realized that you didn't have it commented out anymore.
Yeah.
Yeah, that one.
Right. The other thing that you can also run into, and this is actually, let's demonstrate it here. Come up with a bogus function, right? Def whatever. And I might even put stuff inside of it like print whatever, right? That's my function. That's what it does. Will this ever do anything in this context? Will it do a darn thing? Yeah, you should be shaking your head no. It won't. Why is it not going to do anything? Because I'm never calling it. Does it stop the program from running? No. To get it to work, I have to call it, preferably from the main method. I spell it right though. And there you go. Now it's working. Right. So this is the example of you got to call a function to run it. This one's being called from the main method. If I didn't call the main method, none of this program would do anything. Right. So once again, if I comment that out, run the program, now nothing happens. It's not giving me an error because there's no errors. The error is in my logic, not in the code. Right? See the difference? Right. But you have to have that main method in there. You have to call it to make it run. I try to follow this approach whenever I'm writing complex programs. Right. Because if you have, let's say you have a function that's got like a gazillion steps in it, it's really complicated and is 100 lines long, but you're calling it from your main method where it's just one line of code. Who cares what the 100 lines are? Right. That's the black box. Once again, coming up into play. All right. Saving our work. Moving on to exercise number 2.
Can I ask a quick question, Ty?
Yes, please.
From that I'm slowly getting less confused by this, but it keeps coming up for me where like intuitively I don't really understand how we can keep using the same variable name and it doesn't like trip over itself as it's like like flipping through. Is there like some logic that I'm missing or
No, not at all. This is kind of an interesting phenomenon, Chris. So you guys are picking up on what Chris is really asking, because here I'm using the num variable, and maybe this isn't the part you're even confused about, because I'm running this function and I'm storing the value here, and then I'm outputting it here, right, in this step. And maybe let me pull up my annotation tools. I think that's probably a little better. All right. So I set it up here. This runs, comes down here, returns, let's say it returns this one, whatever. That comes back and gets stored here, and then we're outputting it here. Then we run the function again, it overwrites the value, and we display it again, right? Here, we're calling it, it's not getting stored at all. It's just getting basically added on to the end of the string and going up on the screen. It's not getting stored. So these two approaches are storing the value for output. This one is just brute force putting it on the screen. Now, I go down a couple lines, and now I'm calling the other function, right? I'm calling the average function, which needs somewhere to put it also. And the only function of the num variable in the main method is to put stuff on the screen. That's its only purpose. So if the confusion is, why am I just reusing the same thing? because its only job is to put stuff on the screen. That's the answer, right? If I was using that value to do some other calculation, you would bet I would name it exactly what it is. You know, I would have a more meaningful name aside from num, and I would be careful about not having it pollute other variables. But since this one, its only purpose is to display, doesn't matter at all. The other thing that's kind of interesting here, right? So that might be the one confusion, but there's also this other confusion that when we're defining a function and we have, you know, a parameter list that we're sending in, what this really is a declaration of 3 new variables that only operate inside this block of code. So even though this is named XYZ down here, this XYZ is different than this XYZ. They just happen to be called the same thing. Now, typically, because I come from traditional languages, I try to never, like if I have 2 different functions and I'm sending in generic numbers, I try to never use the same variable names, right? Because right in Java or C#, you're taught that. You're like, don't use the same variable names. You could confuse yourself. In Python, you will notice, whatever, who cares? They're different X's and Y's. And that's kind of how we operate in Python. We kind of throw away that strict rule book and don't worry about it so much because it still works. If it helps your brain to use the same conventions you use in Java or C# or whatever, do that. Intuitively, if I was writing this from scratch and not copy pasting it from the instructions above, you know, because just to remind you that the reason they're there is because they came from here, right? If this one said ABC and this one said XYZ, I would have copy pasted that and not worried about it. But if I was hand coding it, I'd probably use different variable names here. And not because I have to, because I'm uncomfortable because I learned Java in like C languages first. You know, that's the why. And if you're an experienced programmer, you think that. If you're fresh to this stuff, you don't think about it at all. You're like, okay, it's just like you do it in Python, and you just roll forward. But Chris, really good question, because I think it's a pertinent question that others might have as well. All right, let's move on to the next exercise. And then at some point here, we should take a break, I think. All right, let's do exercise number 2. All right, so write the following functions and provide a program to test them. Okay, so these are all the functions we have to write. I'm just going to copy them. We'll sort it out later. Right, so I'm going to go over to Spider to sort it out. Create a new program, save as. Same folder. This is exercise 5.2. And zooming in, pasting in the instructions. So these are the 3 functions we have to write. Once again, they want us to write a program that's going to test them. So I'm going to write one with a main method. So I'm just going to do a main, right? I'm going to have some code here. And then more importantly, I'm going to come back to the margin, go all the way down and make sure I call my main method so I don't forget to do it later, right? And this is one of my habits. If I'm dropping into main, I add the thing to call it right away because otherwise, guaranteed, I will forget, right? Then I'll run it and go, why isn't it working? And then go, oh, duh, no main. All right. So now we need to put stuff inside the main method. However, we need to define some functions, and let's define the first one here, which they're calling def all the same. All right. So I'm going to just drop that in right here. And this one says return true if the arguments are all the same. Okay. Sounds pretty simple. How do we check to see if all the arguments are the same? Well, it's actually super simple, right? Think of the code here. If X is equivalent to Y and X is equivalent to Z, then they're all the same. So I'm just going to type return true. Okay. What if they're not? then we return
False.
Yeah, precisely. Now, could I do this with an if else? Yes. Okay, so that's kind of, this is kind of weird, right, to talk about now. Yeah, I could do this with an if else, because if x doesn't equal y and x doesn't equal z, I could say else, return false. But if this doesn't evaluate, then this will happen anyhow, which is kind of like writing an else, right? So I'm just showing you that that's kind of a way to do it. Another little thing that's kind of interesting, and I'm throwing this in right now because there's kind of like these weird conventions that Python programmers use. And so one of them is like this kind of goofy stuff, right? So like if you're writing a program, you're like, I have all this stuff at the top, right? Because we're in school and whatever. But if you're writing a program and you're sharing it with others and you want to tell them all about it, you might put in some like more verbose comments, you know, like at the top of your program. In fact, you might get into like the ASCII art of it and, you know, make a little box and put your name in there and put a date in there and tell people what the program does. You know, hey, this program does silly stuff for school, you know, or if it did some tangible task like calculate the volume of a cylinder, you would put it there and explain, right? That's a common thing to do. Another thing that Python programmers often do, and the book talks about this a little bit, is they use a convention like this, especially when they're defining their internal functions. And I'm putting plenty of space here. That's probably enough. And then we'll do delete. That kind of looks like this, which is kind of like a header for a function, right? And so, in other words, this block of comments defines what this function does and tells me also what the parameters are accepting as values and what it returns when it runs. So in other words, it's kind of like a micro manual for the function, right? So what does this function do? Determine if three values are all the same. Parameter X, first value, parameter Y, second, parameter Z, final value. And then it returns true if all the values are the same, false otherwise. So, okay, granted, I can kind of figure that out by looking at this code because it's simple. But if the code is really complex and has a bunch of bizarre stuff going on in it, this is really helpful at the top. What does this function do? Oh, okay, I got it. You know, that's the value of this. Do I want you to do this with all your functions? If you were working professionally in a, you know, in a coding house or you're working on a team and they're like, hey, write some functions, you know, it probably insist that you do this, right? You want to document your code. Writing schoolwork, hey, whatever. You know, do it if you wish. I'm just showing it to you because it is a thing, right? And when people build libraries of Python functions, it's kind of a determinant in whether or not it's legit, right? Because the person put in the work to kind of define everything so that this kind of becomes the manual of the functions, you know? All right, so here from the main program to get this one to run and test, we're gonna basically write some code. And yeah, I'm gonna kind of do some copy pasting here to kind of accelerate things a little bit so we can get to our break. So I'm gonna start with a blank print line. So I'm gonna just move it down the line. And then I'm going to do all of this inside of a print statement, right? So in other words, I'm going to just drop in a statement like this. And I'm going to ask the question, are 1, 2, and 3 all the same? And then I'm going to call the function, send in 3 different values. I already know the answer, right? And let's see what it comes back with, right? Let's do the run, right? Are 1, 2, and 3 all the same? False. So even though this is really a Boolean value, it does translate to text in the print statement. I could also, right, use the other approach that I did before, which is set up a variable, run the function, store the value, and then print the value on the screen, right? And then this one, it's not verbose. So are 1, 2, and 3 all the same? False. And this one just says false, but it's 2, 2, and 3. They're not all the same. Just 2 of them are the same. right? To make sure it really works in all scenarios, you want to at least try a few different values, right? So you want to have one, at least in this case, that's going to trip it correctly, right? And then you can have maybe another one here that's kind of like the one without a descriptor, right? So this one should say true, this one should say false, right? And then if I paste it again, if you wanted to like really, test it, change all the values, right? Like 3, like that. Run it. So we have false, that's correct. False, that's correct. True, that's correct. False, that's correct. True, that's correct. Right. So that was the all the same. The next one is kind of a converse, right? All different. Right. So if you want to describe your function, feel free. I'm not going to do that. I think I described the other one well enough, but it would be very similar, right? And how would I determine if all of these don't equal each other? Well, they're all different. In other words, not even two of them can be the same, right? So here's my if statement. I would say if X does not equal Y and X does not equal Z, but Y and Z could still be the same. So I have to do another and Y does not equal Z. Does that cover all the scenarios? Yes, it does. Right. If you're not sure, I assure you that that's the case. All right. So if that's the case, then we return true because they're not the same. We'll just say return true. And then once again, if not, we will just return false.
Can I ask a question, Ty?
Yes, please.
Could you have used the same logic that you have in 38, line 38, but use the inverse, like put them in parentheses and say not, if not, and then the rest will be the same? Could that have worked?
I mean, you're saying if I put all of this in here and put a not in front of it?
Yeah, for the all
for the all different?
Yes. I realize that there's normally more than one way of doing the same thing.
I see where your brain is going with it, but think of it like this, Martin. If X is equal to Y and X is equal to Z, it is implied that Y also equals Z.
Right.
Now, if the converse is true, and this is something you'd have to run the code to make sure, right? But I can just tell you from a logical standpoint that it's not. If you're looking for them to be all different, you have to check the third criteria to verify it. Because if one of them is not, do you understand where I'm going with that from a logical standpoint? Because if the first two are set to be the same, and the second two or these two are set to be the same, well, that means that Y and Z are also the same. The logic is actually adding and Y equals Z here. So I couldn't just negate it because it's leaving out the scenario of checking Y and Z. That's the problem, right? That's a good. That shows me that you're thinking pretty deeply about the if part of it, though, right? He's thinking about the logic, you guys, and maybe your brain doesn't even go there, but this is like a very valid question. So thank you for asking it, Martin.
No problem. Thank you.
All right. Now our goal is to run the all different method. And what I'm going to do here is I have a collection of statements, right? And you guys are going to hate me because I'm just copy pasting it. And so I have one where they're all different in a different order, almost the same. And then one where they're the same, right? So I'm going to run this. We'll still have all the old results there, but all different. All right. True, true, false, false. Oh, We have a failure. And now I'm looking at my code going, why is it failing? Should that second last one be a false? If X does not equal Y, and it doesn't, and X does not equal Z, now I'm looking at my code solution here. I was like, what failed here? And Y does not equal Z. I mean, I think my statement is correct. I'll wait to see what results you guys get. So that this to me is perplexing right now. Try a different scenario here. Just copy one of these. Oh, no, that's correct. I don't know what I'm thinking here. Think of what we're checking. We're checking to see if they're all different. Two of them are the same. Okay, so see, this is like, we're once again, I'm like confusing my own logic here. So this is working just fine. I'm just not thinking about it, right? I'm not checking to see if there's only one different. I'm checking to make sure all three are different, right? That's only true for the first two, right? You guys feeling me? Yeah, okay, good. Or at least pretend like you do. All right, we got one more here, which is, this is kind of a weird one. So this one's called sorted, right? So they gave us the definition. I'm just adding a colon here. So how, okay, so this is asking, let's see what it's asking. Return true if the arguments are sorted with the smallest one coming first. So in other words, the way they're being received is in numerical order. So how do we check to see if something is in numerical order? X, Y, Z. Okay, that's a pretty easy one. If X is less than or equal to Y, and Y is less than or equal to Z, that means they're in order. Simple as that. So once again, return, type it, return true. Otherwise, we return false. All right. I do have some pre-configured statements to test this as well. So here they are. And so I have sorted 1, 2, 3. So this one should return true, false, false, true. That's what it should return. False, false, true. True, false, false, true. True, false, false, true. There we go. All right, folks, I'm going to go ahead and pause the recording. All right, we're going to continue now with exercise 5.3, and you see basically the same type of approach here. We're going to build 3 functions, and they're defined here, and they give us also an example. So I'm going to copy the example as well. I'm going to go on back to my IDE here and make a new program. Do a save as. This will be exercise 5_3. Zooming in just a tad, dropping the instructions in here. Right, so these are the functions that we're going to build. As we've done before, we're going to go ahead and make a main method. So let's just follow that approach, get lots of practice with it. I'm also going to come down a line here, stay on the left margin, and then make sure I call it. And then we'll come up and define our first function, which is going to be first digit. And what this will return is the first digit of the arguments. In other words, it is going to look at a number typed in and give us the first number if the number contains more than one character, basically. Right, so now we got to think of how this would be accomplished. So, all right, well, if they're putting in a number, it's coming in as a number. And so probably the first thing I want to do is convert it to a string. Okay, so I'm going to I'm coming up with a variable. I'm just going to call it string. And I'm going to take and use the string function. By the way, this is a built-in function in Python that takes whatever number you throw in and turns it into a string. So for example, if I throw in the number 1729, it's going to convert it to the string of 1729 with quotes around it, basically. Once I convert it to a string, remember, then I can look at by index position, I can look at each character separately, right? That's kind of the whole thing. All right. Now, we just want to find the first character in that string. So I'm going to make another variable called first. And what's going in there? I'm going to take the string that we just converted, and I'm going to look at the first index number. Remember, with the square brackets? So we're just looking at the first character. And then since we have it now, we can return it. So I'm just going to return first, and then we're done. Another little thing that I might throw at you, and this is just really kind of a side note. What if you want to take that number out of the number and then use it to do math, right? Then you need to turn it back into a number. So you might throw in a piece of code that does this. And I'm not doing this, but I just want to point it out. So if I'm extracting the number so I can do further math with it, I would have to take that number now and turn it back into a number in order to do math. I'm not doing that. I'm just kind of pointing it out. I had it in my notes from last time, so apparently I was talking about it with my previous class. But this is what we're going to do here. Following the same pattern we used before, I'm just going to do a series of print statements here to test this in the main method. So for example, if I do 1729, let's run that. Notice first digit of 1729 is 1. Right? Probably should test it a few times, maybe with a smaller number, a larger number. So let's try it with a single digit number and a 3-digit number and see if it works. Looks like it works in all scenarios. Right, so that's first digit. All right. Here's another one they want us to do, which is, okay, last digit. Well, we got first digit. That seemed pretty easy. Maybe we can do last digit. All right. But with first digit, we just choose that first index position and it always works, right? Yeah. So how do you get the last digit then? All right. This is where mathematical trickery comes to aid you, by the way, right? All right. So I'm going to show you the longhand way to do it, and then I'll show you a clever way to do it. Right. So both of them are perfectly valid, though. And if you have already done the work and have done it like the way that I'm about to show, I'd be totally fine with it. So you could do this. You could say same approach. I'm going to take the string. I'm going to convert that number coming in to a string. And then I want to look at the last position, not the first. And normally what I might do is I would look at the string. I would get the length of the string and subtract 1. So for example, I might go like length of string minus 1, right? Because the length might be, let's say 4, but that means the third position is index value 3. So that's how I get the correct index position. And then I would maybe put that like inside square brackets like this to get to the correct value. And, I'm going to prove to you that this works. And then I'm going to return last, right? So I'll show you what I mean by this. So watch me run this. I'm going to throw in one example piece of code. And I'm just going to take that first print statement basically that I have up here. Right, now we're looking for the last digit. Let's see if it runs. Okay, the last digit of 1729 is 9. So this works. So think about this. I don't know what length the string is going to be. Right. So by probing the length of the string and subtracting 1, it will always match up with the index value of the last position. Here's a clever hack that Python does. And so people from other languages, like if you already know other languages, this is the same technique we use in Java and C# to find the last index position of a string, right? But Python has a really cool shorthand that I'm going to show you that is a little bit, it feels like cheating almost, right? And so this, they have this shorthand technique for expressing the same statement. And take a look at this. You can also do this in Python. So Java, C# coders, JavaScript coders, if you already know those languages and you've worked with, index numbers, you don't have to say length of the string -1. You can just shortcut the whole process and say -1, and that works too. So if I run this program again, it will still give me the right answer. So you might choose this technique. That's the verbose method. You might choose this technique, or there's even a different one. And I think that this one's even more clever because it involves math. And I'm not even going to use a return statement here, right? And what I'll do here is I'll notate this. But here's a really clever way to do this. How mathematically can I extract that last number? All right, check this out. This is so simple. I love it. Basically, this is like one of the reasons why I actually dig math, right? Because numbers are just so cool. I can take the number, mod it by 10, means I'm looking for the remainder. So knowing that this is the tens digit, right? Hundreds, thousands, 10 will divide into that evenly, leaving you with 9 as the remainder. Isn't that clever? Yeah. You don't have to look at index values, right? You don't have to traverse it, store it, convert it. You see how clever that is? That's just incredibly clever, and it's done mathematically. So I don't even have to look. I can just run mod 10. Oh, there it is, 9. Watch it work again. Just show you that it does work, right? And now let's test it with a few different values. So we did the 1729 one, and here's a couple different approaches here, just in case you're chronicling it, right? So 3 other print statements, single digit number, 3-digit number. And then I'm also kind of using a different approach where I'm taking last digit of a number, forcing it into a variable, outputting the variable using string interpolation, by the way. All right, so here comes the run on that. You can see, is it working each time? It sure is. If you don't like the mod approach and you used one of these, I think they're all cool and valid, right? But we did use the mod approach here. So leaving them all in there so you can see them. All right, we got one more function to write, which is called digits. This returns the number of digits in the argument. Okay, interesting. All right, let's define it. Let's put a colon in here. So how would I determine the number of digits? Well, I do still need to convert it to a string, right? Because we're sending in a number, remember, right? So I take and run the string function on the number. Then I will just simply return directly the length of the string. Notice I'm not storing it. I'm just running the length function, and that will be correct. I did need to convert it first. All right, so there's the function definition. And then I need some code to test it with. And basically what I've done here, and I don't know if you guys have picked up on this, I'm just copying all the same print statements, and then I'm tweaking the function calls, right? So these are all different function calls here. All right, so there's the code. Here's the run. Looks like it's doing it correctly, so it's working just fine. This is exercise 5.3. Everybody okay? Not going too fast?
I need to learn how to type faster. I think that's what it's teaching me.
Well, or be clever, more clever about how you copy paste, right? Because like these statements here are basically, you see how they're kind of the same numbers?
Yeah, I remember you told me that in the web programming. You're like, don't try to type all that copy and paste. It's not cheating. Like, I'm like, okay, now I'm learning my lesson in Python.
Yeah. Well, it's like, it's also because we only have so much time together. So I mean, we could, like, I could just sit here and lecture you for 2 hours, and then you could just code by yourself, and good luck.
Right.
I really don't like that approach for teaching, especially intro level programming and even advanced programming, like working on it together and struggling through it. Then you can ask the questions. And then when you ask the why makes more sense when you're coding as opposed to talking about it, reading a book, way more sense. All right, we're going to move on to the next exercise here. And I'm noticing I might circle back, by the way. Okay. Might circle back.
Quick question on Ty, just because this is bothering me. Didn't you say there was something built into Python itself that recognized these values as strings, but we're still converting them to strings? Do you remember what I'm talking about?
Well, right. Okay, so let's look at it like this, Chris. If I was prompting a user to enter this number, it would come in as a string, and I wouldn't have to convert it.
Ah, I see.
You see the difference?
Yeah.
So if I was doing a prompt, I wouldn't even need to convert. But because I know I'm sending in numbers, that's kind of the point.
Got it. That makes sense. Yeah.
Did I have to do it that way? No, I could have sent it in as a string and just saved the trouble, right? But it also gets you to think about that piece. All right. So my grand point was here, I do have a solution for 5.4 that we can go through if we have the time. We might, I'm just looking at the clock here. We might, but our next goal really is to do exercise 5. And so this one tells us what to name it. And basically what we're doing is we're creating a Homer Simpson joke here, I think. Right. So let's create a new file. Save as. This is exercise 5.5 that I'm doing next. I'm skipping over 4, but I might come back to it, by the way. The description is this. Oh. All right, so whatever that said. Write a function called repeat that receives a string, seemingly a number, and then a delimiter, right? That returns the string repeated n number of times, separated by the string delimiter. For example, ho, comma 3, comma space, right? So that's like a parameter, returns ho, ho, ho. Got it? Right. Yeah, that's pretty funny. And then if you change the number to like 3 million, it would do it 3 million times. Which we should test, by the way. All right. So that's kind of our grand goal. We're going to follow the same pattern we've been doing. So we'll do a main method. Here's the main. Parens, colon, couple lines there. We'll come back to the margin. Go down a bit, call main, So we make sure it runs. Then we're going to define this function called repeat, and we're just going to copy the stuff right out of it, right? I do feel a little obliged to explain what a delimiter is, right? So the reason they're calling it delim, a delimiter is just a separating character. So very often we'll work, especially in the data program, really in all programming, with what we call comma separated value files, where the data inside the file is all split apart with commas. And so in other words, I might have and this works with database stuff too, folks, where I might have a person's name, comma, their address, comma, their zip code, right? And the comma becomes the delimiter. It is the separating character. So that's where that comes from. So that's just my quick little explanation of that. All right. So if we're receiving a string, I got to take that string okay, so we want to repeat the word ho, for example, right? So that's what's coming in. So I got to capture that string without changing it, ideally. So for example, I'm going to come up with a variable. I'm going to call it retval, which means return value. This is what I'm going to throw back to the program when I'm all done, right? First, I'm going to feed the string into it, right? So ho came in, now ho is stored here. But now I need to add it over and over again, right? And what I'm going to do, so if I'm adding something over and over again, we have more tools in our arsenal now than we used to have. I can run a loop to do that. I don't have to, for example, manually kind of figure out how to do this. That it won't work, right? So what I'll do is I'll write a for loop right here, and I'll say for I in range. And where are we going to go to? We'll start with 1 repetition, and we'll go from 1 until, well, how many times do they want it repeated? Well, I don't know. They didn't specify yet, right? So we'll have to figure out like how we're going to ask them to do that. So I think we're going to have to ask them for the word that they want repeated, ask them how many times they want it repeated, right? And then what delimiter they want to go in between, right? So this is going to be a number determined by the user is what I'm saying. The n number is going to be determined by our user. Now I'm going to do this thing where I'm going to take that return value, which is basically holding the string. And right now it just says ho, right? And I'm going to add to it or concatenate to it. So I'm going to do plus equals the delimiter, for example, comma space plus the string. So it does that, and it adds comma space and ho to it. And then it repeats comma space, ho, comma space, ho, comma space, ho. It just keeps going for as many times as you've asked it to do it, right? And that's a very, very simple little algorithm, but it will work. And then when it's all done, the return value variable I set up will be full of ho, comma space, ho, comma space, ho, comma space. And it will ultimately end with ho because that's what goes here, right? That's the last character. So then all I really need to do is return it. So all I have to do is return the return value. And I could have called it whatever. That's just what I thought of last time. So I'm just copying it, by the way. All right. Let's go up to the top of the program here, though, and get a little bit of input from our user. So I'm going to do an input string, and I'm going to prompt my user and say something goofy like what I'm copy pasting right now because I don't want to type it, which is input, enter a string to repeat. All right. Then we're going to set up a variable called count, right? And we're going to prompt them and say, how many repetitions? And notice it's coming in as text, but we're turning it into a number. Why? Because we need a number in this spot for the for loop, by the way. It's giving me some warnings. I'm not freaking out. It's telling me I'm assigning these variables, but never using them. I will use them, I assure you. And then we'll set up one more variable and prompt called delimiter. And we're asking, so ultimately we're saying, enter a string to repeat. How many repetitions separated by what? Right? So comma space, a dash, an asterisk, whatever you want. Hash mark, whatever. Doesn't matter. There's our 3 prompts. Now we're just going to basically go right to an output statement. And watch how clever this is. We're just going to say this. And of course, it's indenting too far. So just a print statement, but inside there, I'm calling the repeat function. I'm sending in the input string they want repeated, the number of times, and I'm running out of space here on the side of my keyboard. The number, okay, the string repeated, the number of times, and the separating character. That will come down here, execute, and it'll just drop a string right in here, and it'll print to the screen. That's it. That's all program, believe it or not. All right, check it out. Here comes the run. String to repeat. Let's just do their example. So I'll do hope. How many repetitions? 3 is pretty good, but let's do 5. Separated by, and we'll do comma space. And there you go. All right. Now let's have some fun with it. Right. So whenever you write like code like this that has the potential to create like excessive amounts of output to the screen, it behooves you to try it at least a couple of times, right? If only for the sake of fun, right? So here we go. Enter a string to repeat. Whatever. Okay, it's one of my favorites. And 5 repetitions is a little boring, frankly. Let's do a few more than that. What do you think? Yeah, 1,200,000. Sure. Separated by, let's just do a dash. Here we go. Has anybody got their stopwatch going? It did it. That was 1,200,000, 300, 200,000, 234,000, whatever, right? 1.2 million repetitions of whatever dash. How long did that take? 5 seconds? Kind of interesting, right? And here's kind of a fun thing. Like if you had apples to apples, like, or, okay, PC to PC, and you're comparing the speed of a computer, this is one way you can actually benchmark a machine, honestly, right? Because the action that I'm taking here is a very simple piece of like code. So think about what happened in memory. It captured the information, it called the function, it came down here and ran through the loop 1,234,000 plus times, and then it returned the value to the print statement and put it on the screen, boom, all at once. Interesting, right? Right. And it did not take that long. And I'm just having you like contemplate that thought as well. It did not take very long for that to happen 1.2 million times. So if you guys want to try something goofy like that, you want to push your computer to the limits and see if you can make it crash, because I get programmers that do want to do that kind of goofy stuff. First of all, shut down anything that you're valuing data wise first, and then have it like reiterate some ridiculously long word like 10 billion times, and then calculate how long that took. These are really goofy, nerdy things to do. All right, I admit it, it's super nerdy, but you know what? I kind of do get intrigued by this kind of goofy stuff. Like, what can I do to make it break? And if you don't think that way, maybe you shouldn't be a programmer, or maybe you should. I don't know. Maybe that's bad on my part, is that my brain kind of thinks, all right, well, what can I do to make it break? All right. I thought it would be kind of fun to do the 5.4 exercise since we have the time, If you don't want to hang out for it, that's up to you. Or no, we have another exercise to do, 5.7, don't we? Okay, never mind. I won't come back to 5.4, then we'll do this one because we're almost out of time. All right, so this is our directive. So I apologize. I like totally misspoke. But if you guys want to stick around for the 5.4 solution, I'm happy to provide it. Doing a save as. This is exercise 5_7. And let's put the instructions up here and zoom in. Okay, so write a function called count words that takes a string and returns a count of all the words in the string called string. Words are separated by spaces. For example, count words, Mary had a little lamb, should return 5. Okay, so can you guys think about like how this would really operate? This is kind of an interesting little scenario. How do I know I have 5 words here? Well, I have a word and then a space. A word, a space, a word, a space, a word, a space. So I have 1, 2, 3, 4 spaces. Therefore, I have 5 words. See the logic? So really the number of words is determined by taking the number of spaces and adding 1. That's the basic algorithm for it. So that's what we're going to build here. Once again, main function. Make a little space, call the main function. Now we're going to define our other function called count words. I'll have you notice that they're using camel casing to name it. There are some rules for naming functions, which are very similar to the rules for naming variables. Can't use reserve words, can't start with numbers. I think you can start with an underscore, but maybe you can't start with it or you could include it. But camel casing is probably the most common way to do it. All right. As I'm doing this, right, I'm going to kind of give you first the main program code to help kind of speed things along here a little bit. So I'm going to prompt the user and I'm going to say, enter a string, please, maybe a whole sentence, right? And that's really what we want. We want a bunch of words with spaces in between. And then we're going to call the function. We haven't built it yet, but we're going to call it. And then it's going to return a value or a number. And then I'm going to output it to the screen like this. So that's what's going to steer the program. But I still need to do the work here. All right. So first thing I'm going to do is I'm going to set up a string variable to hold the string, because I'm going to take the string and I'm going to run a built-in function, which is part of the string library, by the way, called strip. Strip is a built-in function or method, you can call it whatever you wish, I suppose, that basically removes the leading and the trailing spaces from a string. Now, this is a really interesting phenomenon, and we were talking about it in the database class kind of briefly, but when a lot of people, when they're interacting with computers and they type words, especially if they get verbose and they're typing sentences and typing a paper or an email or a text message, you type a word, you press space, type a word, you press space, type a word, press period, type a word, press space, type a word, press space. You know, that pattern happens. And if you're starting a new sentence, sometimes you hit a space first and then you start typing, right? You guys know what I'm talking about, because it's pretty normal typing. So users on a computer often have this propensity when they're presented with a input form that sometimes they'll add an extra space to the end of a sentence or the beginning of a sentence. Not because they mean to do it incorrectly, but because they're typing so fast, it just kind of happens, right? Very normal, you know, the example I gave in the database class is very normal. Like if you're like typing in like username, password, a lot of times people who type username space and then hit enter. Why? Because that's just kind of what they do. That's all the people type. So we often use these commands. This is a very common command in a lot of languages to strip the spaces that might precede the string and follow the string. Because if our algorithm is correct, where we count the spaces in between the words and add one, if we have a space at the beginning or a space at the end, it breaks the algorithm, right? So the strip command becomes essential for making sure our algorithm doesn't break, basically. Right? A very common command to add to input text, by the way, right? So if the string equals a blank line, return 0. Now, notice how I did this if statement. There's only one possible result for it. There's not multiple lines of code. I can put it all in one line, just like that. That's perfectly valid, by the way. So that works in Python. All right. So if the string is empty, we return 0, we're all done, right? No further processing necessary. So there's the first return possibility. If not, if we get past it, there is something in there. It's not blank. I'm going to set my count to 1. It's got to be a word in there in that scenario. Now what I'm going to do is I'm going to use a loop again, and I'm going to go through each character in the string. I'm going to traverse it automatically, letter by letter. That's what this statement does. And then if it so happens that that character does not or equals a space, then I'm going to increment my count. I'm just going to go count plus equals 1. So I hit a space. Well, I counted 1 word. Now I hit a space. Count a word, space, count a word, space, and then you should have the right count ideally. And then once you pop out of the loop, you should be able to return the count, whether it was 1 word, 50 words, 1,000 words, whatever, doesn't matter. All right, so here's the code. This is all of it for this exercise, by the way. Once again, it always amazes me how elegantly we can traverse structures in Python. Compared to other languages, it is just blow away simple, right? And powerful, by the way. All right, so here comes the run. Enter a string, maybe a whole sentence. And you know what? Here, let's have some fun with this. And so I'm going to do this. And yes, I'm going to use ChatGPT to do this. Because welcome to the future, folks. What's lorem ipsum? Does anybody know?
Is it a different language?
It is a different language. It's
Isn't it just like filler nonsense?
It is, right? Lorem ipsum is a way that, like, we do this a lot in web and in publishing, by the way, is they have this like nonsense Latin text that they drop in on websites or applications just so we can have some words to throw on the page. It doesn't say anything to us. Maybe if you read Latin, you would know it. So my wife actually studied Latin, so she would know, by the way. So, but I'm going to take this whole darn thing and drop it in. And here, let's have fun with it though, because I'm going to use some external tools to verify what I'm doing. And a lot of people don't know this about Microsoft Word, but if you use Microsoft Word and you drop in some text, it automatically keeps count of the words down here. You see that? Gee, I wonder how it does that. Word space. It does uses the same algorithm, folks, right? All right. Now, whether or not it likes the spelling, that's a whole separate issue, but we know what the count should be. All right. So I'm going to go back in here and yeah, I'm going to paste that in at the command line and press enter. What do you think? Pretty impressively cool, actually, right? I think so. The other fun thing about this is, the thing that goes into your brain is to use a really simple thing like they had as an example. And watch what I do here. I'm going to type space. Mary had a little lamb, space. Still gets the right answer in there. But I do dig the fact that I can run this and then I could, for example, paste lorem ipsum a couple of times, actually, right? And hit enter, and it still comes up with the right number. And how quickly it does it. I mean, that's the other cool part about it, right? It's how quickly it does that processing. All right, so that was exercise 5-7, where it counts the number of words. So I think that that's actually a pretty useful little function, right? You know, like if you you might have use for it. Obviously, in a word processor, this is a thing that they do, and this won't be the first time I do this. So when we start doing a lot of language processing, and we look at you know, Python's capability to really even do this, I often go to Microsoft Word as an example. And by the way, whenever you're typing a Word document, you can see the word count here. Like if your teacher says, I need a paper with minimum of 500 words, right? You know, that kind of thing. So you start like putting in lots of the and to and he and she and whatever. But you can also click this little button here, and it even gives you more information if you guys weren't aware of this, but including the page numbers, words, characters, no spaces, with spaces, paragraphs, et cetera, et cetera, et cetera. Right. And fascinating is we're later on going to run other programs that calculate exactly the same stuff. Right. So this is kind of a helpful little tool if you guys didn't know it was there. All right, we're not saving the lorem ipsum, but now you guys have learned a concept, lorem ipsum. Web designers use this a lot, by the way, when they're building a web page and they want to see what the words look like on the page, but they don't know what the words the client are going to give them. Right. All right. Class is officially done. For anybody that wants to stick out and see the solution to exercise 5-4, I will go ahead and do that. I do want to do one quick little check here. All right, we do have an extra credit exercise, which I never demonstrate those. Those you have to figure out on your own if you want the points. But I am going to demonstrate 5-4. So 5-4 says the following. Have a good night, anybody who's leaving. The rest of you, if you're hanging out to see a little bit more coding
Good
magic.
night.
Good night.
Thank you, sir. Have a good night.
Thank you. All right. I'm going to go over to Spider and code this one through. I think I might get a couple of you to stay. We'll see. All right. I'm going to do a save as here. This is exercise 5-4. Here's the description for that one. Right. So we're going to grab or create a function called middle that returns a string containing the middle character in the string. If the length of the string is odd, right, it grabs the middle character, or the two middle characters if the length of the string is even. Okay, so if you throw in the word middle, it will return DD. If I throw in the word, I don't know, like, you know, if I struck the 1D, then it would just return a single D, or it would return just the middle letter. I'm going to do this pretty quickly, you guys, right? Because I know this isn't concern for anybody since it's not an assignment. But here's my main method. Oh, sorry. That is not my main method. I forgot to hit copy here. Here's my main method. It's going to come back, call it. So you can see I'm prompting the user to enter the info. All right. Here comes my function. I'm going to start by stripping, right? Because we're grabbing an input string, so you don't know if they're going to like add a space at the end or before. So we're going to do the strip command. And then oh, wow. Okay. I apologize here. I don't have the solution on the screen. So I'm noticing that I copy pasted over a previous one. So hang tight for. All right. So I did figure out where that was. So I apologize for those watching the video. Going back to full screen here. So, all right, so I have my basic definitions here, and what I'm really going to struggle with is basically the algorithm of kind of dealing with this. So the first issue I have is, and then I noticed this after the fact, of course, is that the function's called middle, and we're not going to strip the string here. We're going to allow the person to type it in, and then we're going to check to see if the length of the string is 0, right? And so that if that's the case, well, it's empty. We're not returning much, right? Then we'll do another check. We'll check to see if, and I think that this is probably not indented the right level here. It's not. So let's fix that first. And this is because I'm copying from the author, and his indents are a little different than mine. All right, else if the length of the string mod 2 is equal to 0, meaning there's an even number of characters, then we'll return the length. Okay, so we're going to return, be careful about how I say this. We'll check the string length. We'll do integer division by 2 and subtract 1, plus the string length with integer division, right? So in other words, we're trying to determine the middle positions here is what we're doing. By dividing by 2, we're finding the center point, subtracting 1, and then we're also grabbing this position. So we're grabbing the one short of the middle and one past the middle, basically, is what this is doing. Otherwise, we're going to do this. Right, so once again, we're doing integer division on the length of the string. So if you can imagine, like a 4-letter word would return a length of 4. We do integer division of 2. That's going to return 2. We go to the second position, right? 0, 1, 2. Then that's going to be the correct position to basically point out the middle letters. Let's just try it out so you see what I mean. Oh yeah, and see, these are the wrong prompts. All right, so we're gonna stop that program from running. All right, and I got to fix the prompt as well because I have those that are broken. So here's the correct prompt and output statement. So enter a string, and then we'll indicate the middle character. Let's try it. So let's try something simple like I don't know, since middle letter is N. Let's try something with 6 letters. Oh gosh, I can't even think of a 6-letter word. How about we just type in 6 letters in a row here? There we go. And the middle characters are D and F, and that looks correct. All right, so this is working. And I apologize that I was fumbling finding the solution, but this is what happens when you overwrite your own code. And then I couldn't find the solution from the author's files. And I didn't want to sit there and ration through it in my head. So it's late. I'm calling it a night. This video ends here. So that was exercise 5-4.